All right, welcome to Module 4, Weld Joint Geometry, Welding NDE Symbols. Try to break this up into two different parts. One of the things that you will be asked is what defines the definitions of standard welding terms and definitions. We use the AWS A3.0. This 94 version, I think it's still 94 version is current. However, it's been approved by ANSI. ASME and everybody else has adopted it as well. ASME usually writes the standard, American Society of Mechanical Engineers, and then ANSI approves them, right? So ANSI doesn't write any codes or procedures. What they do is approve them for use, make sure they're consistent. Basically, they would do kind of a patent check or a background check to make sure that nobody else is using them and they're not conflicting any other information, which is good because back in the day, there used to be a lot of that happening, which is why we ended up with GTAW instead of TIG, right? SMAW instead of stick welding, because there's a lot of things use a stick, whether it be oxyacetylene or anything else. So these standard terms and definitions are how we make sure to keep nice, clean, precise standards out of our abbreviations and terminology. Basically today we're going to hit up on geometry of joints and welds must be clearly stated. Terminology used for A3.0 and 2.4. Don't use slang terms. We're going to discuss them because that is actually what you hear quite often in the field. However, we want to make sure that you know the proper terminology as well. Welding symbols are the shorthand method, clearly stating exactly what needs to be done. They're basically your recipe book, right? There's still a lot of things you have to decide yourself in there as well, though. Can't figure everything out on your own. I'll read through these. I need to do that. You can always go to 2.4-98. We've got some of these documentation in my office and a book if you want to borrow them. But most of the stuff is online now, where you can find them pretty quick. Okay. So let's remember, particularly, we're talking about a weld joint and versus the weld. They're two different things. It's kind of like a welding symbol and a weld symbol. The weld symbol is actually part of the welding symbol. The welding symbol tells you a lot more than just the weld. It tells you the joint, the prep, the tolerance, the fit up, and everything else. So those are some of the things that we're going to be talking about. So it might be a butt joint, but with a V-groove prep, right? There's only 5 joints. We know that. T, lap, edge, corner, and butt. Correct? Mm-hmm. Yeah. All right. Everything else is the prep within that, right? So a V-groove weld, that's what we call it. The weld will be a V-groove, but it's actually a butt joint with a V-groove preparation. We fill it up from there forth. All right. So the 5 joints. 2 members aligned approximately in the same plane. So let's talk back, weld 3 a little bit. We talked a little bit about feigned surfaces. So here we can see this is a shaded piece. So those feigned surfaces, the 2 things are rubbing. You might see a question that says, the joint between 2 members aligned approximately in the same plane with only 2 feigned surfaces, joining surfaces, okay? Again, here's your preps. It can be bevel groove, flare V groove, J groove, square groove, U groove, V groove, edge flange, braze, and a partridge and a pear tree to foot with, okay? There's a lot of stuff in there. Yeah. A lot of things can be. The most common one that we're associated with is typically going to be your V groove or a straight square groove for thinner material, right? And then occasionally you do get a little bit into even a flare bevel. Corner joint. This is much different. So if you see there's an outside corner joint versus a normal corner joint, a lot of times we talk, one of the big problems with this is that we take a possibility of not breaking down this center piece here. We might get good weld penetration from here to here, and possibly even from here to here, but there's a spot in the middle that it's not going to be a complete joint penetration. So CJP we talked about in a little bit, complete joint penetration versus incomplete joint penetration, and IPJ, all right? But you can always think of, most of us know what a corner joint is. I've always mainly shown you in the shop that we're going to use them in this configuration, but they actually can be over top of each other just like this as well, okay? In this case, basically you're doing an edge weld and a fillet weld. When we bring this piece back here, we're doing a fillet weld, or depending on the way you look at it, it could be a V-groove welding as well, right? But the inside is also always going to be a fillet weld, okay? Number one, it's got a right angle there, or an inside angle, I should say. Again, you can read through most of these. I'm not going to go through all of them. T-joint, very familiar with this. Same thing in this situation. When we do in our shop, we're basically welding fillet welds in here. However, what if the angle of prep, say we take a 3/8 groove plate, we normally do, we put up here, we would cut this down at an angle like this. This would now become a V-groove, or not a V-groove, actually a single vellum groove, because this joint would be prep, and then a fillet weld on the outside, and then the other side would actually be our fillet weld as well. Lap joint, okay. A lot of people say, well, what is this used? This is used for a lot of stuff, very common joint. However, what are the two welds that are associated with the lap joint? It's a V or a fillet weld, right? It's the same thing as a T-joint, as far as weld-wise, okay? The difference here would be the weld size, so your theoretical throat and effective throat and everything else, which we'll talk about here in a few. You typically want to make sure that you have the same height as your actual base metal. Sometimes it gets hard to get a weld higher than that, but it's very easy to get a weld that's concave on a lap joint as well. Usually when I see a lap joint, the first thing I look for is it concave or is it convex, okay? All right, edge joint, basically, this uses a lot. This is used a lot in a lot of different applications. We have a tendency to always think of everything being an incomplete joint or a complete joint penetration. In this situation, we don't necessarily need it. A good example of this, applicable weld, and others as well. I want you to think of road construction equipment. Most stuff that we're going to use. We would put a weld here all the way around the surface. It's only designed to penetrate, say, 1/8 to 1/4 of an inch, okay? Doesn't need to be a full joint preparation. We don't want that whole thing to be solid at this point. Where we would see this would be on, so for example, snowplow. Snowplow is going to run up against the road. Well, you don't want the blade to hit exactly on the road, otherwise it just tears up the asphalt, right? So you want it to set just a little bit above. So you put these, like basically a road bumper underneath of it, and your road bumper can be something just like this. It's built with a spring tension here, it comes down, and you're able to see that rubbing across the bottom. It's got a plate there of a mild surface, and only two things are working along as you're going across the road, all right? For a visual inspection, what happens is, this is the main piece that's going to be hard to fix, okay? So you put 1-inch block, or they call them a bumper block, or something you can throw on them. And when you're walking around that plow at the beginning of the shift, you're not always looking at everything to 100% specification. But this is really easy because number one, they're big, and you can look down there and you can see if that's worn down, and you just know to look at it. And if you start to see that it's missing, it got a broken or a crack, then you know this piece is getting thinner, and you're putting a lot more pressure on the blade, and you're going to start tearing up the asphalt as well. So that's when you come back in, you might be able to weld this back on. You don't want a deep weld because you want it to be able to shear it off if it gets in a bad jam, all right? Some abrasion resistance as well, certain situations in there also. We talk a lot about rock crushers, just because I think they have a tremendous amount of metallurgy in them, as well as good examples throughout. All right, moving on. So we did butt, T, edge, I think we're through it, right? corner joint, T-joint, lap joint, non-edge joint. That was the last one. Okay, in here we talked a little bit about the differences. You can pull this slide up and look. Square bevel, single bevel, double bevel, single J, double J, flange, and round. One thing I want you to think about is round is a lot of times we're dealing with thicker plate, right? It's important to know that your rolled plate usually comes with a conical surface as well, a rounded edge. So if you put that up there against the surface, just a brand new side of plate, sometimes I've had it where they required me to cut that first half-inch off where it was a good 90-degree straight edge. Because at this point, it is technically a flare bevel or a round up next to a square. Instead of being a square butt joint, it's now a flare bevel, which basically what that means is we have a problem getting in here. We have to watch our prep and everything else, okay?
What's the difference between like the double bevel and then the double J?
So it's basically the prep. One is a straight 45 chamfer, the other one is a prep. So here,
But what would be the different uses? Because it looks so minor.
it does, but particularly for certain electrodes as spray transfer. Also, if you come as a double bevel, you have a fine point here, right? So something that burns really hot, spray transfer or flux core, this could be a little bit of an issue, versus this one was commonly used for heavier iron, 7024, most shipbuilding, and it also, the weld would come in and you could put a lot of iron in there and it would fill up in a gradual progression instead of taking a chance of not breaking down this edge. However, as you can tell, the heat affected zone becomes tremendous as well.
Yeah.
And electro slag welding in other situations, this might be a desired prep because you won't burn a hole through. But 7018, in this case, you usually have to put this in with either a 6010 or a 7018. If you do a 7018, you're going to have to come behind it and grind it and back gouge it in. And a lot of times this was a one weld application. This might be an 1/8 inch thick, and they're asking for this root pass to be all in one first pass. So this one you'd see a lot with flux core as well, okay, instead of in that. And your first root weld is supposed to look like that. Consume that all the way without any prep. And then from there you can filter the rest of the way out, which the flux core works pretty good because this stuff's pretty smooth. Right?
Quick.
It is quick. That help answer that?
Yeah.
Okay. And so in this case, it's a double J. On two sides, just a single, or in this case, it's a single J, but two pieces are with a single J instead of a double J as well. There are some cases where you'll get a spacer on a double J. The reason I say that is because this can sometimes be a consumable insert on a TIG. Okay?
Oh, okay.
So your insert pieces here, it's naturally built in as a 332 spacer. It's consumed into the weld. You stack that in there, and it's considered a spacer or an insert. Stack that in there, and basically you don't use anything for your filler metal. That is your filler metal for the first root. It makes it much easier so you're not doing this and guaranteeing penetration. Both joints, you come from both sides, so you weld this one with TIG, and then you come back around this side, and you just fill it in and bring everything to the surface at the same time. Okay? Kind of cheating in my book, but, you know.
The word.
Again,
Oh, faster.
well, exactly, so that's the other point, it depends on the process, right?
Yeah.
So again, I'm coming at it from an educational standpoint, but from a production standpoint, there's a lot less bad welds out there because of stuff like this. So if I'm gonna have less errors and less recalls, then I'm gonna stick with that if I can. Okay? All right. Remember that single bevel, V groove, right? So we're just taking one piece that we're actually prepping. Even though a lot of times our first reaction is say, what's a double bevel? It's actually not, it's a single V groove. The double bevel is for each member. This is one member alone, and then this one as well. When we get to which way the arrows are pointing and which side is prepped, we'll get a little bit more in depth with this. Okay? Fall asleep on there, John?
Mm-hmm.
All right. So we're going to talk a little bit about joint nomenclature. I got a handout I'll get to you folks here in a little bit. Oh, come on now. Right here. These ones show a little better, right? So I want you to sit down and think about this. I got a handout that I'll attach to module 4 as well. It's called Parts of the Weld for a groove plate, square butt versus a fillet weld. But you need to start thinking about where's the fusion face, okay? After it's consumed, that's the groove face, right? The weld interface is how far it penetrates in. This would be our root. The different parts of the weld that we start into. Okay. The root. The root is considered the closest portion of the two members, the closest veined surfaces of any two members of steel. And so vein, it doesn't have to be a wide broad face. If it comes to a point, that's still two veined surfaces. Okay, it's still two edges at the closest point is where the joint root is. No matter whether it's this, so we typically think of the root as this, right? It's somewhat of a, maybe a little bit of a root face or land on pipe or plate. But even when we're doing this lap joint right here, these two pieces where they both are veined, all those edges are considered to be the root at that point, right? So sometimes just a piece of steel on steel is going to show a root, and you're going to think, there's not really a root there. It's not like a butt groove, but it is. The root happens to be these two places right there, that line where they meet. In this case, on the edge weld, it's where there's two lines meet as well, okay? Root's pretty easy for the most part. We can see where the two pieces meet. This one's not very confusing. This is the one where we start to get a little bit more confusing. We've got a groove face versus root edge, root face, okay? So first of all, the groove face. The easiest one that we can associate this with is by far this, right? Groove angle, the two large members of a single bevel groove here. One side is prepped, the other side is square. But these are groove faces. These are groove faces, okay? Our land, when we put on a piece of pipe, it's a groove face, also a root face, because they are at the members to where they can, the two closest pieces. So remember, the groove face can be root face also, okay? All right. Yeah, it all depends on the prep of the material. Number 6, figure 6 here, we're going to be talking about bevel angle, bevel depth, groove angle, radius, and root opening. For the most part, let's talk about groove radius real quick. Groove radius is in the J groove that we talked about, right? The radius is typically only, I shouldn't say that, it's not only associated, it's also associated with a flare groove, which would be a rounded surface like that plate we talked about, or a piece of cold rolled round bar, right? But in this case, groove radius is only associated with this because it does have a rounded surface at the bottom. All right? Most anything else that's prepped as a straight edge or a chamfer is going to be an angle, the groove angle or the bevel angle instead. Okay? So exactly what it says, the groove angle is the two combined, both sides. The most industry standard API runs 30 degrees per side, so total is 60 included, right? You can have your individual bevel angle of one side. That's what this is showing you. This is a bevel angle. In this case, it's called 30 degrees. This one would also be 30 degrees. Together, the groove angle is 60. All right? Okay. It's the same thing, but let's talk about their bevel depth. And when we see that called out on the print, sometimes that can be different. So it's usually typically associated on the left-hand column is in parentheses. It's going to tell us that that's our depth of our bevel. All right. And that's, again, not every weld is designed to be a full joint penetration weld. Sometimes it just needs to be the top. It may be only spec'd or engineered for the top surface. What if this is 10 inches of steel? This might only be the top 1 inch, correct? It may not have to be the full entire 10 inches of steel need to be welded. Okay? Typically, you're not going to see this very often here. When you would see this one would be maybe in an I-beam or an out-of-position place where you're seeing two different bevel angles at the same time. Let you read through that on your own. Single groove welds, since they're only prepped from one side of the material, correct, is typically the way I would think about a single groove versus a double groove that can be prepped from both sides. Sorry, back here. So as you can tell, everything here feeds out one direction. You would weld it from one side only, typically, when you're talking about a single. It's not always true. That the print can call it out, we do a back weld or a vacuum weld on it. But it's been prepped from one side only, or not prepped at all, okay? Naturally, square, single bevel, I'm not gonna beat these to death. You can look through them. You can see what's a J, what's a U, what's a flare bevel, so forth. This right down here is where we get into a flare bevel. So this one's straight one, this one's flared. It's got a bevel section in here. This is a flared V, naturally. Two pieces going together. This is very common in sheet metal, right? Or possibly in construction world, a lot of unistrut, right? A lot of unistrut being welded to a beam, something like that for mechanical support, so forth. You would see situations like this, round tubing welded to a flat plate as well. Or, sorry, square tubing welded to a flat plate as well. Different welds. The upset weld versus the flash weld. I don't know if I've seen an upset weld. Flash weld is typically one that we see. Your upset weld looks more like you would see in the fusion type piping for plastic gas piping. You pull them, you heat them up on two surfaces, you smash them together, and the plastic comes up and it fuses at the same time. Okay. Flash weld is kind of the same thing. Flash weld is actually just like the stud gun we talked about the other day. You take two pieces of pipe. It was very big in Russia for a long time. It was actually invented in Russia. You take two pieces of material, you bring them close together, you pull them apart with electricity, let them heat up and make each other molten